Okay, so my name is Filip Klubička. I am a postdoctoral researcher at ADAPT at the Technological University Dublin, and today I'm going to be briefly talking to you about the nuts and bolts of leveraging large language models, specifically on the use case of of a industry project that we did over the last 2 years that finished early this year, or late last year, on NL2SQL. This was a intersectoral collaborative research project between the ADAPT Center and Huawei Ireland that ran from 2022 to 2024. Notably, it was nominated for an IBEC Award in Outstanding Academic Achievement of the Year late last year, and then about a month ago, we actually won the Tech Excellence Award for Emerging Technology Innovation of the Year, humble brag. Here's, I believe, if it shows up, a picture of myself and John receiving the award. I'm still riding that high. Apologies. Brilliant. So what was the project actually about? What was the goal? The goal was to research and build novel solutions for natural language to SQL translation. This is an open problem even today because it relies on sort of two very different things. One being the understanding of the meaning of a natural language sentence, and then mapping that meaning to a meaningful executable query, in this case SQL. So here's a very simple example. Given a database and a question such as how many singers do we have, we need a system that will output the following SQL query. Why is this relevant? Because in a business-facing or customer-facing setting that uses databases, this allows integration of natural language interfaces to relational databases, which enhances their accessibility for end users, be it clients or employees or whatever, and improves the user experience and reduces the need for expert training. So suddenly you don't necessarily need someone who will write the SQL queries for you if the system is doing it for you automatically, and all you need is proficiency in English, for example, or any language. The approach we took to this was a very high level, and I will keep this high level. If you want more details, there is also a poster somewhere over there where you can ask questions after. We identified key points of optimization in the NL2SQL pipeline. So typically when people design models, there's a lot of focus on number 4 here, which is the model training, hyperparameter tuning, et cetera, all of this, right? But we took a sort of general approach and said, well, what are the other things we can do, right? Turns out you can look at things like data representation, and SQL is not actually the best way to represent SQL when you're doing this kind of thing. You can look at data creation. How do you build your data sets? Do you use synthetic data for this? Applying some kind of data preprocessing methods which improve performance actually quite significantly, which people don't often apply. And then at the other end of it, we also looked at beam re-ranking. I'll talk about that a bit more on the next slide. But overall, our approach was to look at the whole pipeline rather than only one of its aspects, and implements various optimization methods and components that improve the baseline model's performance. And I should note here that this can be a more traditional lightweight model or a large language model. You can apply all of these to either of those. And we created multiple hundreds of component combinations and to identify the best one, and also study their interactions, because just applying everything, turns out, does not give you the best results. So our general sort of goal here, and I guess we wanted to achieve, and I think this graph represents that really nicely, is to sort of raise the performance ceiling of the baseline model by applying these optimizations. So we looked at, because these models work in such a way that before they give you the final answer, they actually generate multiple possible answers and assign them probabilities, and then give you the most likely one. So we said, okay, when the model gives you the wrong one, has it perhaps as an option generated the correct one? And turns out you can even rank models like this. A lot of these models do. So like the baseline accuracy goes up to, let's say, 76% here, but if you look at the top 20 candidates rather than just the first one that it gives you, you can get as high as sort of 84, 85. So our goal here was really to sort of optimize performance and lift that performance ceiling of these models. So what did we learn from this? We learned many valuable things about each of the individual components that we implemented, but generally that all of them can be individually useful, although not always together, but sometimes yes. So there are negative interactions as well as positive interactions that we need to be mindful of. But why am I telling you all of this? Because all of these approaches are task and model agnostic. They can be applied to any model. They can generalize into best practices actually that should generally be adopted. So we're not really talking about just the natural language SQL task. This is something that any sort of model pipeline development should adopt, we feel. And in ADAPT, we have the expertise to implement them to any given NLP pipeline. Other than that, we found that one of the models we built was submitted to a leaderboard, a natural language SQL leaderboard called Spider, which is sort of the leaderboard in the domain. And at the time of submission, it was actually the best system on that leaderboard. However, since then, or rather concurrently, the LLM boom was sort of happening, and all these things have been exploding. And if you look at the leaderboard now, it's really dominated by very much GPT. And I think this is really interesting because in the era of LLMs, we argue that what we did here, this sort of high-level pipeline optimization approach, is as relevant as ever, because it's not always feasible to use large language models in real-world applications or production environments. And building a domain-aligned system that's optimized for a given task can offer satisfactory performance with a smaller memory footprint, development footprint, or carbon footprint. But obviously, we all are very excited about LLMs. So even in the case where you want to use them, these pipeline optimization approaches are still applicable and can help them sort of reach their potential. And we did a pilot study on this even during the project, because we wanted to see, okay, how do these things that we implement sort of pair with a large language model? So we took a Llama model in a zero-shot NL2 setting. So we asked it to produce not only one, but also 20 possible SQLs. We said, assume there is more possible correct answers, give us 20, and let's see how you do. And then we applied our re-ranker, so the model that we built that sort of helps the baseline model choose the correct option, added it on top, and we found examples where our re-ranker improved the baseline performance. However, more interestingly, perhaps, we also found that the baseline performance is really, really low, that Llama was really bad at this task in a zero-shot setting. And we're currently looking into why this is and how this can be maybe optimized. And one of the things we think is cracking prompt engineering actually is really, really important. So what are we currently doing and looking at? How do we apply these pipeline approaches to large language models? And what are the challenges that are sort of connected to this? And I think there are three ways to approach it. So first, what you can obviously do, you can fine-tune your base LLM. You need to know what task you're using, what is your question, what is your research question, what is your problem that you're trying to solve using this LLM, which of the existing LLMs is best suited for your given application. Do you want to go proprietary or open source? And actually, Anya has talked about this earlier as well. It's covered really similar things. These are the questions sort of you need to be asking. How do you integrate it into your application? Do you use off-the-shelf models? Or finally, do you fine-tune it to your own data? Because you probably want to do that. You want it to work in your particular use case. The other thing that's another challenge in this sort of space is the prompt engineering. Because LLMs are very expressive and their outputs are brittle. And this has been shown in a very recent paper. Other than the fact that obviously they produce hallucinations, they're also sensitive to the smallest variation in prompts. So you could ask them the same question, but slightly vary the order of examples, or you could add a full stop, or if you write something in caps lock rather than like upper caps, lowercase, you get very, very different results. So this paper compared different prompts, and I'm not saying different, like completely different questions, the same core question, but just a different sort of surface level formatting of the prompt. And if you compare different systems, given these prompts, you can find that, you know, if you use prompt 1, turns out ChatGPT is really bad at a task, but if you use prompt 4, it's the best out of the 4 systems. So there's a challenge here in like, how do you model this and how do you approach this? Do you do zero shot? Do you do few shot? Do you use chain of thought or in context learning? And none of these are really straightforward to implement. There's a lot of human sort of work that maybe is taken for granted, but requires significant manual work to develop and test the best performing prompt template. And in fact, if you want to mitigate against this, the best strategy is to evaluate against a pool of prompts. So you use different prompts and then you average on them and say, okay, this is how the system actually performs. Because you can't control how your user is going to write the prompt, right? And then finally, once you get the prompt right, you have a system, how do you evaluate it, right? And there are a lot of questions here because large language models are state-of-the-art on everything, which makes their evaluation subjective and difficult to automate. So there's questions around what metrics do you use? Do you use single value, n-gram-based, fine-grained, and specialized metrics for a task? And then do you use, other than automatic evaluation, you can use human evaluation, which is obviously expensive. There's a trade-off here between cost and speed. Human evaluator time versus engineer development time, or do you use other language models as evaluators of language models, which brings us a step closer to Skynet. And so finally, just to say, so to leverage LLMs, I believe, requires expertise on two very different fronts. On an engineering front in terms of the fine-tuning, and then on a linguistics front on doing the prompts and sort of the evaluation of these systems in all different ways you want to evaluate them. And I think what's great about ADAPT is that it operates on the sort of intersection of language and AI, and we have the research and development expertise to provide both. We can leverage LLMs by applying pipeline optimization approaches, fine-tuning to domains and tasks that are tailored to your own institutions and data, and provide expert machine learning evaluation, whether that's human or automatic. I think that's me. Thanks so much.
Thank you very much, Filip. Hold on. Just hold a second. That's great, Filip. Thanks very much for that. That's fantastic. That's great. And being close to the project, closer than other projects. Congratulations on the award. Do we have any questions from the floor for Filip? And hands up in case I don't. Nope. All good. Filip, you explained it so well. Well done. Thanks very much, Filip.